Hello, am I audible?
Yes, sir.
Okay. So I think we'll move a little more faster. Okay, automata, I thought finite automata I'll take in detail. Then remaining all automata will move faster and then we'll move into complexity analysis. Okay. So here we have seen all representation, okay, three representations of this example machine. That is a transition diagram, transition table, then a quintuplet representation. So here transition functions I have not written all, few I have written. I hope all of you are getting how we are writing this transition function. Delta of s comma p, that is state s and input to p, next state will be a. State A, input to W, we are moving to state A1, or state transition is happening to A1, so we are representing like this. Okay, so like this we need to write all states, okay, all transitions for all the states. This is how we are representing a finite machine, finite automata machine. Now we'll see next type of automata, that is push down automata. Here we'll be adding one more memory component, that is stack. Okay, stack, all of us know what is stack. It is having two operations, push and pop. So we need to consider one more parameter along with our transitions. So whenever we are giving input, machine will read input and state transition will happen. Along with that, it is going to push something into the stack. Okay, so what is going to push into the stack, that also has to decide. So transition function or control function will be controlling state transition along with the stack content also. Okay, so here the representation we can see total 7 components will be there. That is Q set of states, same as previous example. What are the states we are using to represent the machine? All the states together we are representing as capital letter Q, then a sigma input symbols, okay, or alphabet in the language of the machine. Then stack symbols. What are the symbols we are pushing into the stack? That is what tau, then a delta transfer function, remaining all same meaning. Here two things are new, that is we are using stack, okay, set of all the stack symbol, initial stack symbol z0. Two things are new, remaining 5 have same meaning. Okay, so we'll just see how it is working. You are having input type, and input type we are having the set of alphabet, that means your string. Okay, and your machine will be reading from the left most location to right, towards right side with the initial state. Okay, and you will be having a stack. Initially the stack will be empty, but you are considering something in initial stack symbol. Why this is required is, in with respect to a digital system or digital computer, whenever you are running your program, only not only that program, okay, so many other programs parallelly running into the system. And your memory stack or main memory we are dividing into uh, basically three. One is for a residential monitoring system, or resident monitoring system, that is operating system, and one part we are using for stack, another part for heap. So this stack, okay, the memory stack may already have some other program details. So we should not touch on that programs. Okay, your program should run, or your system should run without disturbing others. So whatever already there, we are considering like a Z0 or initial stack symbol. And the remaining things you are going to push. So here input, in this case sigma, okay, that is input symbols A and B. Okay, and whenever you are reading A, suppose you are pushing X to the stack. Whenever you are reading B, you are pushing Y to the stack. Then your stack symbols are, okay, that is tau will be set of X comma Y. That is a difference between sigma and stack. Okay, tau. Sigma represents, in the representation, sigma represents input symbols, that means alphabet of your programming language. And tau represents stack symbols or language of the stack. Okay. And what are the symbols you are using to push into the stack? That's x comma y. Okay. These symbols we are representing as tau. Okay. Then uh, remaining all same. Okay. Now we'll go for bounded machine. In case of bounded automata, again we are having the sigma and all same meaning. Okay, input alphabet here, sigma E, yeah, I'm using. Okay, so T type alphabet. Okay, so there's a difference between type alphabet and input alphabet. I'll tell you what it is. Then initial state Q0, then final state. Okay, and a transfer function delta. Okay, so just I will take one example and tell you what is type symbol and input symbol, what is the difference. So in bounded automata, the concept is you are having an infinite type. Okay, and how much string you can put into that. So the input type will be infinite. Okay, so your input string will be putting in the memory. That means your program is loading to the memory. Okay, so suppose like this A, B, A, something. But in this case, you will be having bounded with a limited memory space. Your memory will be very big, but you are giving boundary or limitation for your input type. Okay, and this input type will be bounded within the bounded symbols. Suppose I am using dollar symbol. Okay, so your program will be putting within, or program in the sense here input string will be putting within the boundary or within the specific location. Okay, means within the boundary. So further you cannot add anything into this. And your head, okay, read head, in case of automata and push on automata, you are able to read only one direction, but here you are able to read in both direction, and you are having read and write capacity. So whenever you are reading a symbol, you will be able to replace the symbol with a new symbol. Okay, so whenever you are representing your transition function, present state and input, okay, it will be deciding what is the next state. Okay, and what is the direction of movement of your head, and what you are going to replace. Suppose you are replacing A with X, so you will be representing three things. So that means once you are giving an input on a state, your machine will decide what will be the next state and what direction you are going to read next. Means randomly you are going to access your memory within the bounded limits. That is what bounded automata. But in previous cases, in both push down automata and finite machine, we don't have the capacity to read and write on the same memory location. And in both cases, in previous both cases, you will be able to read only in one direction. Okay, in tour machine again, you are having the concept of unlimited memory space. Okay, and you will not have any boundary here. You are keeping some input memory, input string on the memory, and you are reading. Okay, and then your read and write head. You are using read and write head to access from the memory, and you are connecting with the control function delta, and this control function will decide what is in state, direction of movement, and write back symbol on the tape. Okay, it is same as bounded automata. Only the thing here, you will not have boundary for your string. In previous case, you have the boundary, but here we have one additional thing, that is empty locations. We have to represent it using some symbol for that blank symbol. Okay, so suppose I am using capital B as blank symbol. Okay, so so your machine will read from one side to other side. Once you are reaching B or once you are reaching blank symbol, you will come to know your the present string is over. so that you can have another string also here. Okay, after the B you can have another string. Okay, so that you can have multiple programs to run on the system. Okay, so that is what tour machine. Okay, so now we need to connect this idea with our quantum machines as well as our algorithms. So we'll just see how we can use these ideas for designing the algorithm. Okay, so for designing the algorithm, what we'll do, we will understand the problem definition or requirements. Okay, then what kind of computational power we are having, or what kind of computation system we are having, we'll understand that, and we will make a step-by-step procedure to get the task to be done. Whatever the task we need to achieve through the system. So that means we should understand limitations of the system, and we should understand what is the problem and how to solve the problem using the limited resources or the system. Okay, then we are going to design the step-by-step process, that is algorithm. And then once algorithm is ready, we cannot believe the algorithm as it is, or 100% we cannot believe the algorithm. Then we need to analyze the algorithm, whether the algorithm is suitable or it is better than the existing one. If we are designing a worst algorithm compared to the existing one, then no need to follow that algorithm for like application development and all. You may have get a solution, but if it is worst, then we will not follow. Okay, so we need to analyze. Then once analysis giving the better result, we'll go for writing the program or that code the algorithm for the implementation purpose. Okay, then this is a normal procedure what we will follow to design any kind of algorithms. Now we look into this automata concept. Okay, in automata we are giving input from the memory, that is our tape. The system will be reading, and at last the system will reach a final state. That means the system will say the input is acceptable or not. Sometimes the system will not reach the final state, means it is rejecting the input. Anyhow, we will get some kind of output after processing through automata. Same, okay, the procedure what we are following to design an algorithm and implement, we have a computer system. So that means we understood what system we are having, what are the powers or abilities of our system, that we will understand. Okay, then the problem definition we will understand, and based on that we are making the step-by-step procedure. And once this algorithm is ready, what kind of input we require to give to our system, our computer system, and what is the output we are getting. These things we are understanding. Then, if you are analyzing the computer system, okay, while executing the program, we will understand whether our algorithm is efficient or not. That is a basic idea. Okay, that means we have the computer system, we know what is how it is executing our program. So we just observe our computer system and they give the input. By observing the system, we are understanding whether our procedure or what are the algorithm we developed, whether it is efficient or not. Okay, so this is what the importance of automata system or automata concept in algorithm design. Okay, so I think most of us will be knowing Alan Turing. I want to just give a glance about Alan Turing. And there is a Turing machine. Just we have seen the Turing machine how it is. Okay, so and with that name, his name, the machine name also a Turing machine, and ACM, IEEE ACM, they are having a award, ACM award. It is considering as Nobel Prize in computing. Okay, so this some history things, and here you can see the concept of Turing machine, actual implementation. Okay, conceptual implementation of Turing machine. You have the tape, and in tape you can see ones, zeros, and all. Okay, and there is a read and write head. So it will be punching on the tape for 0 and 1, and it may be replacing the existing. Okay, So this concept, you can see that the top input tape, finite control, and the read write head, which can move left or right. Okay, and it can read and write on the same tape. That is the idea. In the green color you can see here. Okay, this you can see. And the same concept we will use for our quantum machines. That means quantum automata machine. Okay, this is just a quantum automata, not Turing machine. Next slide we'll see quantum Turing machine also. So here the basic idea is make the you are having the tape which is having input string. So you can see that input string can be any of the state. Okay, some parameters will be influencing on the quantum system, and these parameters will be uh, causing or maybe reason for state changes of the qubit what we are using in the system. Okay, you can see that get 0 or 1. Okay, so as a designer, whenever we are making the algorithm, we'll be knowing the problem definition, and we know what is quantum system, what are the strengths of our system or quantum circuit in the sense. Okay, we as of now we don't have a specific like a general purpose system, quantum system. So for any task, we are designing a quantum circuit and we are running the circuit. Actually, it is like a microcontroller kind of thing. A specific reason we are making the system, okay, making the circuit and giving the input, and we are observing the result. So we know what are the components we are using, what are the properties of the components what we are using, and what are the inputs, and how to use this component property effectively to get the proper result. Okay, so in any quantum system we are having the circuits. Okay, and so many state changes are happening to the qubit or circuit, and at last we are reading the output. Okay, so this u and u sigma, these things and all, some parameters of your quantum system. It can be qubit 0, ket 0, ket 1, or whatever. It is again up to the designer who is designing the algorithm. Okay, so there are papers published on this field. I have taken this image from one of the published paper in elsewhere. And again, another one is quantum Turing machine concept. Okay, so I'm not going to other things, just automata. So this is a basic one what we have seen in detail in the beginning. Okay, then Turing machine we have seen. So we will be giving more importance for Turing machine because Turing machine is having highest expressive power, means maximum type of languages we can represent using Turing machine. That means automata languages. That means maximum problems, type of problem we can address with the Turing machine. So this is a basic idea. It is like a hybrid mode. You will be having multi-tape Turing machine. Okay, assuming that you are having a multi-tape Turing machine, and in this multi-tape Turing machine, we will be having one input tape, and it is read-only mode. One second. Okay, so then tape will be the input program will be loading to input tape. I mean meeting. So what are the program we are giving? It will be in the input tape, and it will be reading input. Okay, then parallelly you may have classical work type. Here classical work type means here classical programs or digital system, how it is working, that okay, to represent the program which is loading to digital system. Then you may have a qubit tape. That means is where we are uploading these qubits. Okay, qubit properties. Then in classical Turing machine, how it is, we are giving a sequence of input. It is reading, okay, and reading the input one by one, and at last whether it is reaching the acceptance state or not. That we'll see. Similarly, in quantum Turing machine, okay, so we are having a tape with the quantum parameters as input, and it will be reading the parameters, and state changes are happening. At last, whether our system is getting the expected result or not, that we are going to see here. Okay, then we'll say why Turing machine is required in algorithm design. We'll come into this one, algorithm design plus how we can use this algorithm design concept and the Turing machine concept in terms of quantum systems. Okay, so this thesis submitted by Church and Turing together. So according to their thesis, their finding was any physical system, okay, related to computation, or what are the physical system we can use for computation purpose, it can be represented by or simulated by a Turing machine. That means in reverse, if you are able to make Turing machine, okay, there will be a solution for the problem using the specific system. That means if you are able to make a Turing machine for the system, okay, whatever the computer physical system what you are using, it can be a silicon, means our digital systems, okay, modern digital computers, or it can be DNA computation, or it may be neuron systems, okay, whatever we are using for computation purpose, that computational algorithm we will be able to make using a Turing machine, or in reverse. If you are able to represent those algorithm using a Turing machine, it is possible to execute the same task in the respective physical system. Only the thing is the physical realization should be suitable for the Turing machine. Okay, that means whenever you are selecting the states and the state transitions, it should be with respect to the physical system what you are using. Okay, so that means if you are having a string, valid string in any language, so that valid string, we can for the valid string we will have a Turing machine. Okay, so the Turing machine again, if we are going for algorithm design, as of now we have seen if we are having a string, the string we can represent it using a Turing machine. That means string here it is a program. What it is an algorithm. Program means it is an algorithm. Okay. So if we are having an algorithm, we are able to make or design Turing machine for that, corresponding to the string or corresponding to the program. Then once you are having a Turing machine, you define the Turing machine as a function, or consider the Turing machine as a function with respect to time, or time complexity. We'll say in detail. Okay. Then the time, whatever the time function we are considering, okay, consider the input for the time function as an binary, means our digital system, or okay, input string. Then the deterministic time of required function, or okay, can be represented using the Turing machines, or Turing machine language. The language of the Turing machine will decide the time complexity of the uh, function. That means if you are making a Turing machine for your algorithm, then accepted language of the Turing machine means what are the suitable string for the language, or what are the acceptable string for the language. These input strings will decide time, okay, or time complexity. That means how much time or efficiency representation for the specific Turing machine. Okay, we'll see this in some detail. So any analysis, algorithm analysis, will be determining whether the algorithm is very poor or fair enough for this execution, or good, it is a good algorithm, or it is a great achievement, or it is having highest like performance. Okay, that will be the output of the analysis for any analysis. So by analyzing various problems, okay, exist or identified in the universe, means for in perspective of human requirements, uh, there are different types or classes of problems. Okay, one is P, NP, B, BQP, QM is quantum machine algorithms. Okay, then NP hard, like so many are there. Okay, we'll see everything, all classes in detail. Okay, so if your problem is into the class of P, that means it is very easy to analyze, to execute in the classical system. That means what are the algorithms executable in the classical system using a program, means you are able to run the program in the classical system, then it will come under P type. So in the reverse order, if you are thinking in reverse order, we are making a if you, once you are having an algorithm, you analyze the algorithm and identify what class or which type of the algorithm you are having. If it is class P, okay, if it is type P algorithm, that means it is executable in the system. You can write the program and execute. Okay, but if it is NP type, okay, that's the importance of analyzing the algorithm and classifying the programs. If it is deterministic, okay, and again, if it is P type, we can have deterministic Turing machine. Okay, deterministic type of Turing machine to represent the P type algorithm. Okay, then if it is NP, non P means polynomial. That means any algorithm what we are designing, you can have a polynomial representation for the algorithm. That means to represent your algorithm, you can have a polynomial. Okay, and based on the polynomial property, we can determine the property of the program or algorithm. Okay, then we have another type, this non-polynomial or non-deterministic polynomial type, that is NP. And sometimes your program will not be into this polynomial type as well as non-polynomial, and you can means non-polynomial, non-deterministic polynomial algorithms also can be executable, but it will be difficult to identify whether it is uh, executing, or it will take a lot of time to analyze. And the NP hard type, NP hard means it is non-deterministic polynomial, but very difficult. It will take long time. You will not have a specific solution for that. That is NP hard. It will come out of the bound, all these classes. Okay. Then in terms of quantum systems, quantum machine system, uh, all programs what is executable in digital system, that is which is representable by Turing machine, that is P type, can be executed in quantum machines. Again, few things can be executed in quantum machines but not in classical system. That is why the shape goes like that, BQP. Okay, so because here probability based algorithms will come. Okay, so these things will see in detail. uh, I think this analysis of algorithm, all of us know the basic theory. I'm just skipping this. Okay, so time complexity and space complexity we will be analyzing. Time complexity means how much time it is taking. Okay, how much time it will take to execute. That is time complexity. Basically, in our digital system, time means not like a second. How many clock cycles? Because any digital system, our computer microprocessor will be executing one instruction per clock cycle. So, what is the clock frequency? How much clock frequency we require to complete the task? That we can say like a time requirement for the program. Okay, if it is 10 hertz uh, processor, then that many in 1 second, that many instructions only you can do, maximum. Okay, but it is, if it is 10 kilohertz, means again 10,000 times it is faster than the first one. So again, it is depending on the hardware what we are using. If you are telling like a clocks, that many clocks. Okay, but in normal analysis, okay, in normal analysis case, we will not see specific clock number of clocks and all, but how many times this loop will be executing, or how many number of instructions are executing, that will not going to change anywhere. Suppose if you are following one algorithm in Intel system or IBM system, which is having two different clock cycle, but number of instructions for execution, okay, for us, for that specific program, that is not going to change. Suppose one program is using 10 instructions to complete the task. So whether it is executing in Intel system, it is using the 10 instruction. If it is a high speed another system, IBM maybe the frequency may be 10,000 extra, but again same the 10 number of lines it is going to execute. Okay, so whenever we are having algorithm, we will be for analysis purpose we will be using this idea. Okay, the number of instructions to be executed to complete the task. That will be in our uh, main task. So you can see in the screen. So if you are having a code, okay, so actually in the C program, we can initialize the code. We can take value from the clock of the system. Then you complete your task. Then again you measure the clock. Okay, the count, clock count. Then you can find out how many clock cycles you use to complete the task. Okay, so this is a exact precision calculation. So normally we will not go in that much in depth for algorithm analysis. Okay, we'll see how many times and the max equal to AI. This assignment will be happening how many times? N times. Okay, because you are putting your task in a loop, and that loop will be uh, looping how many times? 1 to, okay, that I is equal to 1 and till I is equal to I less than n, means n minus 1. Okay, so that many times it will be running. Okay, so we can say this loop will be running uh, n minus 1 to n minus, okay, n minus 1 time, and then first you are having one instruction, and again in the clock, okay, start clock 1 here, then n minus 1 plus 4 we can say, okay, in general. So similarly, okay, so uh, for doing this task, basically what we'll do is we'll take problem. Okay, for that what kind of input we are using, and what is the size of the input, and what are the operations used to complete the task. Then based on this we will have an analysis, and then that analysis will give uh, what is the efficiency of the algorithm. Okay, to represent this algorithm efficiency, we will be using different uh, symbols, that is asymptotic notations. Okay, so before going to asymptotic notation, I just show what is, okay, how we are analyzing the algorithms, and then here we need to find out what is p and polynomial representation and how it will be useful. Okay, so suppose in this example program we are counting how many times it is running. Okay, so then after counting we will come to know, okay, uh, the total execution time. So the total, if you are counting, this will be like a 4 plus n minus 1. I can say 4 plus n minus 1. Okay, n minus 1 time this for loop will execute plus that 4 instructions. 4 plus 1, okay, 5, total 5. 5 plus n minus 1. See, this is a polynomial representation, right? 5 plus n minus 1. This is a polynomial. So any algorithm which can represent using a polynomial, then it is known as p-type algorithm. Now try to connect with this. Okay, in this Venn diagram, that inside innermost you can see p. So that means any algorithm which is able to represent using a polynomial. Okay, that is polynomial type. That kind of algorithms generally will call as polynomial type algorithm. And all polynomial type algorithms we can represent using Turing machine. Okay, that means for any task, if you are able to make a Turing machine, that obviously the task is represented, can be represented using Turing machine, and it can be executed in the system. Okay, so that means it is solvable and it can be run in polynomial time. In this case, the maximum execution time will be n. Okay, so that again we'll see. Suppose what are the polynomial you are getting? It can be n or n. It will have different components. Then, if you are looking to the table, okay, you are putting value for n, then log n square and all. You just observe here. So, which is increasing very high, that is factorial. Okay, for small values, almost all will be looking similar. Once we are moving down, okay, downwards in this table, for the last values and all, okay, means if value is increasing, the function value also increasing very high. Okay, then if you are having any polynomial like a n square plus 5, so if n is equal to 5, what will happen? N is equal to 5, your function will become 30. If it is 50, then it will be 2505. So your function and your n value, okay, the total function value and your n square value is almost equal for large values. That means we will call this n square time. Okay, this is as dominant factor for the polynomial. So for any polynomial which is having the highest exponent, or which is having the highest degree in your component, that component is known as dominant factor in the polynomial. So we'll to represent the complete polynomial, we can use the dominant factor as signature. Okay, just to keep this in mind, whenever we are going for asymptotic notation, this is required. Okay, and the growth rate of any function, okay, it will be like this. Uh, One is we'll consider like a constant. Okay, 1 and log base 2 here, log base 2, because usually we are using binary system, so log base 2 n, then n log n, because log 2n will have some value and we are multiplying with n, that's why n log n is coming above n, then n square n cube, like that. So this is a growth rate. So suppose we are having two polynomials. What is the importance of this growth rate analysis is, suppose one polynomial n square plus 5 means you are, whenever you are analyzing your algorithm, okay, your algorithm 1, you are getting the execution time like a n square plus 5. In another algorithm, you are getting like a n cube plus 2n square. Then we need to find out which algorithm is best. Okay, with respect to both, which algorithm is best. Then we should know what is a dominant factor. Here n square, this is n cube. So now n square and n cube, which is more according to the growth rate, n cube will be growing faster than n square. That means for large amount of input, polynomial with the n cube will be executing faster than, will be taking more time compared to n square. Okay, that means it will require more time to complete the task. Okay, so that is a basic idea on this growth rate. So here we can see how this analysis, or how to get the polynomial out of the algorithm. One small example. Okay, so you will be taking each one, how many times it is executing. So this is one like that, and you can see here while loop. Okay, this while loop, how many times it is running? It will be running this n times, right? Inside the while loop, these two things will be executing, 1 plus 1. These two things will be executing within this while loop. How many times? Based on the n. If n is equal to 10, uh, I is equal to 0, 0 to 9, it will run. Means 10 times it will run. Okay. If you are in good n, okay, this condition, n is 100, 100 times it will be running. So the total execution of your algorithm is completely depending on this n. Okay, so here we are having 3 into n plus n plus 3 into n to the power of 0. Means the first, this is actual polynomial. Here highest degree n to the power of 1. So this will be deciding the total execution delay of your program. Okay, that is a meaning. So we'll go move into asymptotic notations. These are the analysis. Okay, so representation methods to show the efficiency of the system. So basically, we are having three analysis things: big O and big omega and theta. Okay, so here big O means the, you can see the first one. Okay, first diagram. Your Tn is your function, and the order of Gn is the function what we are taking as dominant factor. See, suppose we are having a polynomial function to represent the algorithm as 2n cube plus n. Okay, 2n cube plus n. Okay, see here what is your dominant factor? N cube. Okay, so this n cube, usually we will take this n cube as g of n. Okay, what is the order of g here? And this total function we will consider as t of n. This is how we will consider. Then if there is a function g of n which can grow more than your function t of n, okay, then if there exists g of n, okay, then we can say that is big O notation. Okay, that is what you can see here. Okay, same thing if you are having the polynomial, uh, then in the dominant factor we are taking, and if you are able to find out a function which will be growing smaller than, okay, which will be growing smaller than your total function, that is g of n is a dominant factor, and that will be growing smaller than your actual function, then we will say it as omega or big omega. Okay, that will consider as best case in the algorithm. Then theta average case, you can see. You will be, if you are able to find out two dominant functions from your task, okay, task function, then you may be multiplying with the okay, gn into c1 into gn. You have a dominant function, and if you are able to find out the c1 and c2, two constants, okay, so that c1 gn will be growing faster than your function, and the c2 gn will be growing less than your function, so that your function will always in between these two boundaries. Okay, so this notation or representation is known as average case notation. Okay, this time this example you can see. Okay, now we'll go for different classes. We have seen p. Okay, here what are the function we are finding? See here, to this algorithm, what are the example I have taken, 2n q plus n, this is a polynomial. That means whenever I am analyzing my function I am able to represent using a polynomial. Okay. So now we can see here different complexity classes. If it is in P type, means if your algorithm is able to represent polynomial, using a polynomial, then we can say it is a P type algorithm, and most of the coding problem what we are able to execute in our digital system, it is P type. Okay. Then if we are having a problem and we are able to identify solution for that, but there's no general solution for that. Okay. That is known as non-deterministic polynomial. Means the solution is there, but the solution cannot determine you as using a specific number of steps. It is varies. Okay, situation to situation. For example, graph coloring, or suppose we are taking map. Okay, for each country to country, that order of coloring may change, or number of color requirement may change. Okay, so that we can color, but in which order, how many colors required, those things are not vary. So there's no specific general purpose algorithm. There is a solution, there is an algorithm, but for input to input it will vary. That is what this NP type. Okay. Another is co-NP. Okay, that is complement NP. That is, you may have solution in NP case, but complement NP means this will not have solution. Okay, P and NP is P is having complete solution, NP is having solution. Okay, then co-NP, it is complement of NP. Okay, that means opposite. Okay, then NP hard, you may have solution, but it cannot have like a very hard to find out the solution whether it is existing or not, whether the solution is existing or not. Okay, then we can see NP complete, any algorithm which is which is NP and NP hard, means you have the solution, but you can find out whether it is correct or not with a little more effort. Okay, so it is non-deterministic nature, but we are getting the solution. That is NP complete. Okay, so this classification we are able to identify in quantum systems also. Okay, so here the main problem with the quantum systems are, okay, it is probability based. Means in normal digital system, it is specific nature, 0 and 1. Okay, 0 means 0. Means once we are making this quantization, okay, voltage above 3 volt, above 3 volt, we can consider, suppose we are taking one, like a voltage 1 to 2, we are taking as 0. That means anyhow, whenever we are reading the input, or whenever we are sensing the voltage, we are getting a voltage level, and we are converting to 0 or 1. Exactly, we know what it is, 0 or 1. But in quantum systems, it is not like that. It is not like exactly 0 or 1. It is based on the existence of the what parameter we are reading. Okay, whether it is photon polarization, what is a polarization angle, if you are using photon system. If you are using quantum, like a atomic system, okay, means electron. What is the position of electron? Or what is the spinning situation or state of the electron, whether it is clockwise or anti-clockwise. Again, we cannot fix the axis. Then, what is the probability of getting clockwise on that particular angle? Okay, so probability based. So you can see uh, different type of classes: BQB, bounded error quantum polynomial, bounded. Okay, quantum polynomial. Then BPP, you can see uh, that is bounded polynomial, probability based polynomial. The P is obviously our normal P type. Then see here two branches. Okay, polynomial type. Then this is a hierarchy, and the NP non-polynomial and bounded polynomial. Then error polynomial. Then quantum machines, quantum machine algorithms, QMA, and QMA from the exactly PP and P space. This PP and P space only for QMA, not for classical systems. Okay, so again, the advantage of this quantum classes or quantum algorithms, it will be growing. Okay, in the order of root root n. Okay, not in the order of exponent. Okay, so down you can see one small table here, table over here. See here. Okay, so in normal systems or no, a classical system, the algorithm may be executed in cube or n square order, but here in quantum systems it will be on the order of root. Okay, means to the exponent of 1 by 2, because here in quantum systems almost all calculations are executing parallelly, or parallel executions are happening, so the work will be dividing into small pieces, means continuous division will be happening to your input task. So then it is not accumulating or it is not multiplying, it is dividing continuously. Continuous division will make the exponent radical exponent, that is uh, the exponent radical exponent will come. Okay, so to the power of 1 by 2, to the power of 1 by 3 or something, so that the time requirement will be reducing drastically. Okay, so I hope okay this clear. Will go for, I'll just come out of this slideshow. We'll see what kind of questions. Can we read this?
Any questions? Thank you, Dr. Jinesh. Thank you for the session. And are there any questions, sir? Can we relate this phenomena to Markov chain? Some question was there.
Okay, just to see.
Over. Can we relate this phenomena to
Yes,
Markov chain or Markov process? Is the question.
yes, sir. Most of the quantum algorithms, okay, most of the quantum algorithms are using probability concept. So uh, this complex, specifically here, I'm targeting about Turing machine as well as uh, algorithm analysis. So anyhow, the algorithm which is existing, okay, which is already developed for quantum systems, all based on the probability concept, because our sensing, okay, quantum sensing is based on the probability. Okay, so Markov is applicable for this. So whenever we are designing for Turing machine, going for design Turing machine, we need to take Markov into account.
Right. Okay, sir.
So,
Thank you so much for your time, Jinesh sir. Thank you for your lecture.
okay,
And it's a joy for me to again, be back here as we conclude today's session. Let me give you a few announcements. Let me make few announcements. Jaykumar sir also has joined us. Dr. Jaykumar, welcome and thank you for joining. So there are a few questions about the quiz. The schedule is given to you. So we will send you the details by email. There will be 20 questions, okay, which will be given and you will have to answer in 30 minutes. and this will start after the exam, after the class is over. It starts at 4 o'clock, and it is not from 4 to 4:30, right? So for those who are new, it will go on to next day, right? It will go on till the next day evening, right? Midnight. So let us say the exam starts on, let us say 17th, right? So 17th it starts and goes on till 18th, 12 midnight. So 18, 12 midnight, you have 24 hours. Till 17 midnight, you have 8 hours. So something like 32 hours is given. Within this 32 hours, any time you can take 30 minutes. I hope I am clear. So there will be 20 questions which you have to answer, multiple choice. Please be sure only one small thing that you need to note is that there will be, what do you say, multiple answers may be correct. More than one answers may be correct, right? So it is not one answer correct questions. There may be two questions or three, two options or three options out of the four may be correct, or all four may also be correct. So you will have to be careful about that. So these are two things that I just wanted to share with you, right? So please don't worry about the time. 32 hours is good enough. Quiz will be posted on Canvas. So once you log in into Canvas, you will see you've been visiting the files for looking at the slides. You've been visiting the modules to look at the video recordings. So you can visit the quizzes that will be there. So once you click on quizzes, you will be showing quiz 1, quiz 2, quiz 3, like that will come. So only first the quiz 1 will be visible from tomorrow. After the class, it will be visible. So you can look at that and take the question. Time increase, sir, 1 hour, because the 20 questions will not be very difficult. Don't worry. So they can be very easily answered in 30 minutes, right? So please try to, that's the experience. Mostly people, sometimes if you study well, you will answer in about 10 minutes itself. All the questions you just have to click. So don't worry. Timing is 30 minutes, any time from tomorrow 4 o'clock, that is 17th 4 o'clock, goes up till 18th midnight. 18th midnight is like you have about 32 hours. So please don't worry about it. Dummy paper. See, it's any multiple choice question. You would have done so many multiple choice questions in your life, right? Yeah. If you have some friends who have already done QT-01, 02, 03, so yeah, you are putting MSQs, not MCQs. So we have to check all options, right? Yes, you have to check all options, which all options may be correct. So there may be more than one options which are correct. So anyway, there are a few hints. As you get the experience, you will be able to answer. You will understand which has more. There are no negative marks. There are no negative marks. 30 minutes is more than enough. In fact, we want to give 20 marks, 20 minutes, 1 minute per question. It will be less than 1 minute per question, right? Please keep it light. The teachers have been asked to be moderate. A few questions will be easy, few questions will be tough. So a few questions will be straight, you can answer very easily. So getting 40% marks is very easy. That's what I can say. If you don't prepare, you will get 0. Still, you can guess some questions, I think. But if you're able to write the questions, then yeah, there will be problems also. You'll have to solve the problem and give the correct answer. Sometimes numericals are there, yes. Qualifying marks is 40%. Yes, only 8 marks out of 20 you need to get. And also we'll give you an option of what do you say, averaging on three quizzes. That's what we'll try to do, right? The last we used to have the 4th quiz on the last day, but now we are doing only 3 quizzes. So you can take average of 3 quizzes also. You can get. Don't worry. See the teachers who are giving. Kumar sir is here, Jinesh sir is here, or Ashwat Babu sir is there. So they are all routine teachers who are basically have taught in engineering colleges, and they know the level of who are attending and what is their this thing. But definitely they want to try. Yeah. Session will be till today, I think. Yes, sessions will be till today. Tomorrow's content will not be there. Or check up. Tomorrow's question is not there. Till Jinesh sir's lecture will be included in the syllabus. So they will be contributing to the questions. So 20 questions will be given by different faculty members. So you'll have to answer the questions, right? Yeah. The choice is with the teachers, not with me. So I cannot do the things. The PPTs are already shared on the slides. Yeah, see, some of the questions are slightly difficult. Because kind of automated theory and advanced topics are covered. So hopefully it should not be the thing. Can we leave now? Is attendance done? Attendance is always done automatic. So please don't worry about attendance. Attendance will be taken if you have logged in. The attendance is there, and the attendance is also maintained in the files section. Please go to the file section. Every day's attendance is marked. Please check whether you are marked present or absent, and we will check 75% attendance in all the sections. Okay, we are trying to look at how to do it. We're also looking at time being taken. What do you say? Time, the duration with which you are active also is given by WebEx. Please take the thing seriously. So hopefully, at what time will be the exam? Link for the exam. Link for the exam will be in Canvas. Exam time will be o'clock till next day, midnight, 12 o'clock. Any time you can take the quiz. Right? So is that okay? Okay. But I think Dinesh sir may give 2 or 3 questions only, so don't worry. They will not add up to that 40 minimum you have to take. Yeah. I understand MSQ takes. That's why that extra 10 minutes is given. Otherwise, 1 mark per question. And most of the questions, some of the questions are this thing. Quiz is open from 4 o'clock tomorrow till next day midnight. So 4 o'clock on 17th July to 12 midnight or 11:59 midnight of 18th July. Any 30 minutes you can take the exam, right? So I think that should be fine. Yeah, please, those who have not joined Canvas will not be able to take the exam. Please look at the videos that were shared, how to join WebEx and how to join Canvas. Please contact your friends who have already done the previous courses, how to join Canvas and what is the issue with Canvas. We will help you. And if you can continue tomorrow after the class, we'll also give you a demo on how to join Canvas. That's what we can help. That's the maximum we can help. Yeah, thank you so much for your feedback. Time I've already mentioned. We'll mail you. Don't worry, we'll mail you. Regarding the Google Sheet where you have to give the names, please don't add the names. Anna, we have now removed the access, so we'll try to look at how to do it. Actually, I don't know. We are all teachers. There is no feedback link. No daily feedback link is needed. For joining the course, you have to do registration on WebEx. For joining Canvas, you have to do registration on Canvas. Then only you will be able to join. Canvas, you cannot add yourself to the course. We have already added you to the course. You just log in and you will get. Use the same email ID as much as possible. Only thing is you should not use the teacher mode of Canvas. You have to use the student mode of Canvas. Right? Please be sure about that. And I think yeah, please look at the mail that you have received, Canvas from Canvas Free for Teachers. There will be an email from that. So please look at that email and you can very easily join. That email only will help you. Going to Canvas app or going to Canvas website will not be helpful. Go to the Canvas email, Canvas Free for Teachers email that you have received on your registered email, and just log in, and then you will get the access. Check the files for the slides that are there. Dinesh sir will also share his slides, so we'll put that online. Then look for the video recordings in modules. Look for attendance also in files, and quizzes will be under the link quizzes. Right? Yeah. Unko unmute karo, Sushil Kumar Azad. We need to install only Canvas Student. Yes, Canvas Student is what option you need to use and join. Right? Yeah. Yeah, Sushil ji, please speak.
Yes, sir. Actually,
yes.
Sir, I just need to know. Yesterday, I received a mail where there was some Excel file, and we had to fill the name faculty.
You
Ourselves.
did not have to fill your name. Actually, that was the problem. See, all the names are there. You just have to search for your name and edit if there are any mistakes in the organization. Doctor, Mr., Mrs. That you have to add. That's all.
But I
Only
didn't
doctor, professor.
find. Sorry, sir. I'm sorry. I didn't find my name, so I added myself the last name there, last row.
You
Added myself in the last row, my name, because in the list,
right. Actually,
maybe I missed it because it was a long list of 1,300 candidates. So I was unable to search because.
yeah.
So I hope it is okay. Or
Yeah, you are from Rajdhani.
Right, but now at present in Manav Rachna University.
Manav Rachna University. Yes, Manav Rachna University. Your mail ID is rajdhani.du.ac.in.
Yes, sir.
So this only you just had to add doctor and check whether your name is correct, right? It was in serial number. It was in serial number 1110.
1110. Okay. I'm professor or doctor, same thing. No? Want to
You want professor? We'll put the professor.
Professor.
PRO.
Yeah, please. Okay, I'll do it today. Thank you.
Anyway, we are trying to look at an alternate option because many have modified somebody else's data also, which we have purposefully written. So I was telling them, don't write that. If you write that, we will change others' data. They did it, right? Some of the friends maybe out of fun, right? So now we are sending, what do you say? We are sending the simple details of are you able to see this? You have shared? Share kar dijiye. We are sending a small Google form, which we did last time also. But all of you will not fill the Google form. That's another issue. So best please record in this Google form. Salutation, you will have all the options. 5 options will be there. So please fill these options: Professor, Doctor, Mr., Mrs., and Miss. Right? Most of you are able to see this, right? And then you have to fill the name correctly. Right? The example is there. My name is given as an example. So in the it will be in pre-filled actually. The Google form will be pre-filled for you. So do that. And like Reva University, you want to have R capital or REVA capital and U capital in university, you can make those changes, right? So this is something which you can do. A mobile number you can enter and then a registered email ID, because that is where we are able to check that, right? So email ID used on Canvas also we need to check, because we are going to get the result from Canvas. We have to map with the what this name certificate name, right? So that's why all these things have been done. So this we will share now. Please use this and edit this, right? Thank you so much. So we'll देखो किसी का है क्या access? No, now we have removed the access, so we will share this Google form. Don't worry about it, right? Yeah. In the Canvas, we have the YouTube videos are there and the slides are also there. Yes. एक बार खोल देना, slides लगा है क्या? हाँ, एक बार दिखा दो. See, you have to go to Canvas like this. Let me just open Canvas. नहीं open है क्या? हाँ, Canvas open है देखो. See, Canvas will be like this. If you go to left side, you go to the course. You have to select the course. Your quantum computation QT-05 will be available. Select that course. Go to files. Okay, once you click on this, you'll be able to see files. Go to files. Under files, you'll be able to see the attendance and then the course material. Right? You click on course material, then respective teachers' names will be there. So Dr. Ashwath Babu's slides are there, material and class notes, and the images, that class running notes image is there, and also your what do you say, Python notebooks are there, Jupyter notebooks are there. So all this material is there. Then if you look at modules, there you will have the recordings, right? These are the recordings. So they are readily available here. Quizzes will come here now. Quiz will come here once the quiz is being set. So you'll be able to see this tomorrow only. You'll be able to access this at 4 o'clock. Right? Under files, you will see attendance also. Files, attendance. You will see attendance, and attendance, day-wise attendance PDF is loaded. So 4 days are over. 4 days attendance is there. So you can, today's attendance will be uploaded just now. Right? So we finished 5 days already. So wish you all the best for your exams. We'll share the Google form link in WhatsApp also. It will come by email actually. because it will come as a personalized email, right? Right. All those who are showing unauthorized, please send a snapshot and on your email, right? Email on fdb.academy. The mail type email is being typed in the chat box. So please send an email with your screenshot while you are getting that you can look at and do that. Is all the problem. You can look at it. You can also share on WhatsApp to Dr. Satya or Dr. myself. Screen stuck. Sometimes, yeah, sometimes the screen may get stuck. That's an issue. Yeah, we'll try to look at that. Yeah, thank you so much.